Have you ever looked at your laptop or phone and watched it freeze and thought, maybe I need a supercomputer to handle my 12 tabs of Crunchyroll? Well, Tesla had a similar thought, but add in some high-speed highways and a sprinkle of autonomous driving. Today, we're looking at how Tesla quite literally saved their AI ambitions by mixing chips and utilizing chiplets, which consequently changed the course of the future of AI and represents a significant step in the history of AI. First things first, let's break down the mixed chip systems and chiplets. In the good old days, our trusty computers just had one kind of processor, the CPU, but then things got serious. We started adding GPUs for graphics, NPUs for neural tasks, and so on. This is what we call a mixed chip system. Basically, CPUs are like the overworked boss, the GPUs are the creative team that colors, the NPUs, they're like the quirky data scientists in the corner trying to figure out if a blob on the road is a traffic cone or a UFO. But here's where it gets juicy. Chiplets. You know the viral crumble cookies? They are delicious but messy, pretty large, and contain about 1,000 calories, but for an extra charge, they offer you a splitting tool that breaks up the monster cookie. Chiplets are kind of like that. Smaller, specialized pieces of a bigger chip. Individually, they're easier to manage, build, and most importantly, cool. Okay, so why does Tesla care about these chips and chiplets? Well, Tesla has a problem. A good problem. Every Tesla on the road is a data collecting beast. Cameras, radar, sensors, constantly collecting data to improve that sweet self-driving AI. Every Tesla has to know the difference between a traffic cone, a stop sign, and an old lady crossing the road. That takes a lot of data, and the data needs processing fast. The challenge is all this data requires a supercomputer to handle it, but if Tesla just used a giant monolithic chip, it'd be like trying to put out a fire with a garden hose. They get too hot, too inefficient, and they can't handle the specialized tasks of AI demands. So Tesla built a Dojo supercomputer. Tesla didn't just want any supercomputer, they wanted one that's super efficient, modular, and can think fast by mixed chip systems with chiplets. Instead of building one gigantic chip, which could be expensive and not very robust, they use chiplets to build Dojo like a set of blocks. Each chiplet does one thing really well, and they can be combined in different ways depending on the workload. And the best part? Yes, that's right, gamers, liquid cooling. So what does this mean for Tesla and their cars? It means faster AI training. The chiplet architecture allows Tesla to train their neural networks more effectively because each chiplet is doing its job at peak performance. It also allows for real-time processing, which means a safer driving experience and more responsive autonomous features. Plus, by avoiding those ginormous chips, Tesla saved a ton of money. Chiplets aren't just cool, they're cheaper to produce, have better yields, and keep low operational costs. Now listen up for my final thoughts. Before you comment something about how chiplets have been in use for decades, I will follow up and say that they've been used very sparingly for specific purposes. Tesla certainly played a significant role in popularizing chiplet architecture, forcing AMD and Intel to adopt chiplet architectures for their processors. Now people are using them worldwide for desktop PCs, workstations, and servers. And of course, every supercomputer that's used for AI.